the purpose of this course being that it's not for people to design transmission lines or to design overhead lines. It's for people that are trying to build their stuff next to them.
Yep. It is an introductory course to a world that is generally very closed if you're not part of the utility industry.
Very much so. Quite honestly, before I was in the electric utility industry, it's the whole, we need to get great, there's a power line there. Now what? Who do we call? I don't know. We can do the utility locates. The only number I can find for anybody is customer service. Let's punt. They'll show up at the final design inspection. It'll be okay.
And I had a different experience in doing a lot of local roadway work prior to and local commercial work prior to moving into substation construction. All my experience was, oh, you need to call this guy in the planning department over here who is a utility construction planner, not part of engineering, not just like, he's the guy who comes out and is like, we're going to need 3 poles and I'm going to need 2 line trucks out here to move this, and here's your bill. So a lot of my experience like early on was just like, yeah, you just call the utilities and you tell them what they're going to do, and they hand you a bill and you walk away.
Yeah, and 90% of the time, that's what works, and that's what happens. And as I think we've both learned, some of the infrastructure out there is pretty substantial, and it's not the, oh yeah, we'll have 2 bucket trucks come out next week and we'll get it done.
Yes.
So with that, I think that's largely what this course is. I think what do we have? Overhead power and infrastructure, basically.
Yep.
I think personal introduction is probably in order. Basically, why should people listen to us? and
yeah,
largely it's that we know what we're doing. So my name's Kyle. I'm a professional engineer, transportation engineer, actually. 3 years ago, got a job doing project management in the power industry. And then over the past 3 years, I've learned a lot of stuff that I have thought, wow, that would have been nice to know before. And Joel, how about you?
Joel Bice. I'm a construction management major. Kyle forgot to mention that he's a PE as well, who I believe is after much research and deliberation, I'm now have now figured out I'm qualified for my PE, so I have to go through that fun process.
Yes.
But I have like 13 years in construction management, 10 of those being in the power side, three primarily focused on substation design and construction, and the other 7 have now been in transmission. I guess 4 in substation design, 6 in transmission and distribution, primarily focused as a standards engineer. So my job is mainly, I make lots of drawings. I have to learn a lot and try to design as we build in the field, not just pump out drawings and work out of the office. So again, I'm with Kyle. I've moved between a lot of industries, and I basically have done a lot of learning as I go along. And there's a lot of things, especially when it comes to transmission and distribution, which is what we're really focusing on today, that is not, it's not intuitive. They've made it not intuitive.
Well, I mean, and you get the most pedantic people from each engineering discipline to all get together and come up with the standards of how to do this stuff.
Yep.
So,
and there's a lot of constraints that you'll see in other areas too that we deal with here, and most of the most of the wild ideas have to deal with people, and the not wild ideas have to do with stuff that folks who don't deal with it every day don't think about or consider.
Yeah, it's really the intersection of each engineering discipline's blind spot.
Mm-hmm.
So I think the next thing, housekeeping wise, so however entertaining we try to be, you're watching us to get PDHs. And the cool thing is, it's our favorite word, free.
Yes.
So you go to engigma.com, engigma.com. You'll be able to sign in. There's 2 levels of registration. We will set up a light registration just for the PDHs. Make sure you subscribe to our channel. That we plan on pumping out at least 15 hours of qualifications of, yes, this fulfills requirements for PDHs. So it is somewhat technically intensive. We aren't going to really be doing much for calculations. We'll direct you to where you have information on how to do a few calculations, mostly to not get electrocuted. But this is very much life, health, and safety, because we're keeping you safe, your surveyors safe, and also making sure that we don't, fault out a line through a truck.
Yes.
Of the motoring public.
Yeah. Or cause a line drop or any other sort of highly dangerous condition when you're discussing overhead power in really any voltage class.
Yes, which brings us to our first subject.
Yeah.
Great transition, by the way.
Do you like my lead in? Okay.
That was a very good lead in. Transmission, basically we have 3 different voltage classes: transmission, distribution, and service. Service, they should know service, because when you mess around on your own house and you're not really taking the precautions that you would at work, is probably the most likely you are to get electrocuted.
Yeah, that's true. It's the less than 1 kV is generally considered a service, and that's usually coming off of your service transformer, which, if it's overhead, it's the little round. Yeah, there we go. I gotta find it's the little round can up on the utility pole. I'm sure I've got some pictures somewhere. We might insert a picture in here with some flavor text or something along those lines. Or if you're underground, I can literally go outside of my house, or Kyle can go outside of his house.
Absolutely.
The underground transformer that will feed those homes. Now the service is the lowest voltage, like I said, below 1 kV. Now, generally speaking, surveyors, diggers, 99% of contacts with overhead lines or conflicts with overhead lines are going to be services. The good news is, generally speaking, you can contact your local utility representative, whoever that may be. We'll get into that later. They're easy to move, easy for the utility company to deal with, easy to disconnect. Those lower voltages for a utility mean that they're very easy to handle things. And that's what you'll notice through this whole conversation is just like any other utility, the larger you get, the more painful it is to deal with. So we were not, I mean, that's probably all the time we need to spend on services.
I think so. I guess one thing, spoiler on the underground service transformer, it's a green box.
Yeah. Yeah. You have a green box or a gray cylinder. There's some wires coming off of it. Generally, if you have the gray cylinder, it's killed a few squirrels in your area. If you have them. That's about the sum total.
excuse me, spoiler on the squirrels. Future PDH.
Probably there's a lot of stuff going on in that particular area if you're talking about wildfire and that type of connectivity when you're talking about wildlife context with lines. And it's an area that where I actually got really involved early on. So yes.
Yeah. So that'll be, I think in the future we'll do lessons learned.
Yes.
Hopefully we get some input from our viewers, and we can do like a nationwide lesson learned. I don't know if it'll be quarterly, annually, but I think we could probably get some pretty good stories.
Well, I'm sure we could get a lot of interesting feedback on lessons learned. So
Yes.
we're gonna bump up to the next voltage class, which is again usually what you see going around town, which is distribution. Now, distribution is an interesting voltage class because normal distribution, what they call distribution, is between, and again, this is generalized because distribution is a little bit fuzzy depending on where you go on the high end. The low end, it's over 1 kV to 69 kV is generally considered distribution. Now, 34.5 and 69 kV are the common distribution voltages at the top end of distribution. A lot of times utilities will class them as sub-transmission, or they won't class them as transmission, but they'll be treated more similarly to a transmission line. The normal distribution you're going to find are things in the what I'm going to call the 5 kV class are very they're low voltage, high amperage circuits. They're older. They're generally built to tighter clearances, and most utilities are trying to get rid of them. If you run into one, you might give them a great excuse to upgrade to what is considered a more modern voltage class. It's not modern, it's not more modern, it's just most systems are designed that way, and that's how modern system design goes. I'm not a distribution planner. I can't tell you all the ins and outs of why it's better or worse, either than generally speaking, 15 and 25 kV are more commonly used. They have fewer line loss issues. They generally run at lower amperage, are considered slightly safer. Just again, that's what you're going to see in most towns around the US today. Smaller towns, older systems, you'll also see a lot of the 5 kV or 4 kV class, depending on how you want to call it. Again, a lot of times if you run into some of those things, utilities tend to want to get rid of it and will. So something to keep in mind. It's always good to call the utility before you start your early in your project, because they may get out of your way for free or consider it a win if you contact them early when it comes to distribution, specifically in those classes. 34.5 and especially 69 kV, we're really getting into the closer to the transmission class. And what you'll find is as we get closer to the transmission class, the rules begin to become a lot more stringent. Specifically, a couple of things you'll hear us reference: NERC, FERC, and NESC. NERC and FERC, not going to be as thoroughly covered in this course, but just be aware that there are federal entities that dictate how your requests can be processed at the utility. NESC is just a safety code. Again, if you're working with the utility, they'll give you their interpretation of that. Generally speaking, most utilities want to help you out, especially when it comes to distribution. 69 kV is where you're going to start running into roadblocks because their outage timelines begin to stretch. It's not a week or two, it's you have to have things 30, 60, 120 days in advance before they can do anything at all, if you're even allowed to. And that brings us into transmission. And normally in the United States, transmission is 115 to 750 kV. There are systems outside of the US. Again, we both work in the US. We're doing PDHs for our US folks, 750. There might be 1,000 kV system or two out there. I've generally worked in the central US, smaller systems. I know of some 750 that's out there. I know there's a ton of 500 in California. So again, these bigger systems do exist. More commonly, you're going to find 115, 131, or excuse me, 134. Oh man. Yeah, see, I mean, you worked with a lot of 130 class systems, but 115, 235, 345, again, up to 500 kVA, generally your more normally seen systems. Just remember, the bigger and uglier it is, the longer you're out, your pre-outage requirements, and the more difficult it is to get the utility to do anything to that line. So I think that's the big takeaway from the voltage classes is one, service lines are easy to deal with, distribution become more difficult, transmission can range from you can deal with them to they're not going to allow you to do anything for years possibly on that line when it comes to your piece of adding or changing something in that. So just when you're making plans, you need to be aware of those timelines and how those utilities are going to treat those classes. Again, the bigger and uglier it looks, the less likely you are to get an exception or to get somebody at a utility to let you change or move something around.
Yeah. And if something needs to be moved, pretty much the higher the voltage, the more it costs.
Yeah. A good way to look at it is services are usually hundreds of dollars. Distribution is at least thousands of dollars to tens of thousands. Transmission, you're talking hundreds of thousands to millions of dollars. Just as a general rule, again, there's always exceptions, but
millions happens pretty quickly.
Yes,
especially with the inflation in commodities we've seen recently.
Yeah, for sure. And again, you're going to see it continue with current trends in the engineering space. So just be prepared. Make sure that the people you work for are prepared.
Yeah, for sure. So the next topic we have on here, who owns the line? How do you figure out? So one, it's hard enough to get a hold of somebody when you do know whose line it is. So how do you figure this out? And the cool thing on transmission is just Google it. There are free GIS data sets available online. On the same page that we have our quiz on our website, we have a study guide as well, or a reference guide, because you're probably not going to remember everything. It's great. Print it out, bookmark it, whichever. Actually, probably bookmark it. Then you don't have to clutter paper. Just go to our website. We have it there. And I have a link to, I think it was one of the government entities that had it out there. There's others also. Like I said, just search online. You will find a GIS data set that has all the transmission lines out there, and it says what voltage they are and who owns it.
I mean, absolute worst case, you're in the field, something's going on, you have a last minute realization. Follow the line to the nearest substation. There'll be a giant sign on the front gate with a number to call if there isn't one already on the pole. But again, just most utilities, especially when it comes to their physical assets, aren't trying to keep it a secret. In fact, like Kyle said, there's a ton of available data, but I know that there are also times when you are out on location or something's going on. I mean, sometimes that whole, okay, follow the line to somewhere. And that somewhere will usually have a big sign on the front that says, do not enter. If you see something, call this number.
Very good point. For some reason, that slipped my mind entirely. That yeah, we put those signs on the substations all the time. So
yeah, it's like we want people to call if something's burning up in a substation.
Yeah, although if you see something burning up at a substation, follow the line the other way.
Yeah, yeah. You also probably would just want to call emergency services at that point, but that's just me.
And then they'll show up and look at it and say, yeah, I'm not going in there. I wouldn't go in there. But so the next one was distribution. How do you find out who owns the line? Nice thing, one call.
Yep.
Most stuff is underground. I would say most in urban areas. So most of the projects you're going to have are going to be urban areas, you know, other than we're kind of outliers where we work. So
yeah.
Yeah. You know, the other part would be most of the time companies are going to have distribution lines in their service territories. You can go to your state regulator. Their websites normally have service territory maps. And there may be a few outliers where there's a distribution substation on the edge of a service territory or something, but generally you're going to have distribution lines in the service territory.
The other thing that you can run into are what are called shared assets. Don't worry about it. If you get a hold of one of the owners, one of them is responsible for doing all the maintenance and service on that asset. So again, if you see something weird, just call one. They'll direct you to where you need to go. There's a great example of that within our service territory, something where we have some substations that are owned by multiple entities. And we are actually the minority entity and the other entity, but we do all the service work on said asset. Again, it's one of those situations. It's not uncommon, but usually somebody is doing the work to come in and service that asset if you need it serviced. So like I said, there's some weird technical stuff. If you run into it, don't panic. Just call either of the owners and they will know exactly what to do.
Yeah, sounds good. I think we can move on to our next one, which is working in the proximity of the line. Several things here. So there are tables and clearance distances based on voltage and elevation available from OSHA. And they have two values. One is a qualified worker and one is not. This audience are not qualified workers.
It's pretty easy. If you don't know what the qualifications for qualified worker are, you aren't one. But also, generally speaking, there's two ways to get qualified workers. You hire a pre-qualified contractor through the company that owns the asset, or you hire the company's employees who are qualified workers to work on the asset. Depends on where you're at, who you're working for. All qualified workers are some form of apprentice or journeyman lineman. Whether or not they're union depends on your location, where you're working. Generally speaking, they're all great professional guys and they do a very good job. But yeah, there's a lot of training that goes into qualified workers, and each utility actually has quite a bit of say in what denotes qualified or not qualified in their system. I think that's the big takeaway from this. So you can't just be like, oh, I hired these guys and they're qualified workers. Even if they are all journeyman linemen who can do the work, they still might not know some system specific switching procedures, or they might not be trained in some system specific items. So again, just something to keep in mind when it comes to qualified workers. You almost have to default to the utility, or at least be in some, or at least have them provide you a list of companies that employ qualified workers.
Yeah. And, you know, I think for this audience, what the takeaway on this needs to be is you're going to have a geotech crew out there. Make sure that they know their clearances. Most of them that I've worked with seem to know the clearances pretty well. They know where to look them up on OSHA. I believe, I'm pretty sure that I have that link in the reference guide for this course as well. So definitely check that out. Make sure that you're not getting close enough for a phase to ground fault. Also, your surveyors. With some weird terrain, there's potential for a level rod to get into a clearance zone. Make sure your survey crew knows this. I've been survey technician in the past, you know, college intern. I didn't know this at the time, so it'd be a good thing to let your survey staff know, your field staff. Also, your construction observation staff, knowing when a piece of equipment's getting too close, knowing to stay away from that piece of equipment. If I was in consulting, I wouldn't necessarily be having have your construction observation staff know clearances well enough that they can stop the contractor before they do something stupid. I think is really the takeaway. It's important. We want everybody to go home, but there's also the whole not dictating your contractor safety. And I understand that concern as well. But just make sure that people know what those clearance zones are.
Yeah, you do have tables R3 and R4 out of OSHA linked, which are minimum approach distances. So the other that kind of leads into the next piece, which would be I believe that's access rules for transmission versus distribution.
Yes, because there was the
I guess we can discuss
communications. Yes.
So the next group that kind of falls in between are comms workers. Now, I know, again, not everybody here is going to be working with comms workers, but I think it is important if you're a communications engineer, you should know this. But having worked with communications groups and teams, it is just a part of this refresher we'd like to put in. There's a zone called the communication zone that is a working zone that is outside of clearances where communications are allowed to be attached to distribution assets. There's a whole bunch of interesting FCC versus NERC FERC rulings with this. Basically, it's a pissing match between two federal agencies. Not going to go there, but what I'll say about it is there's a comm zone. Comms are to be put there. Communication workers should be aware of where these comm zones are. There are instances and areas where communications companies are allowed to put comms within the electrical delivery zone. Unless you're if you're a new comms engineer, it's a good area of study. If you're anyone else, don't worry about it. And the big thing with this is comms comms employees don't have to be qualified workers. They can work in the comm zone. It is very close to minimum approach distances. It is generally one of the highest risk jobs on a pole outside of line crew work, on or around a pole outside of line crew work. Right now, comms are only allowed with assets that are considered distribution, which would be 34.5 kV and below, because of weird sub-transmission rules. This may change in the future. Again, there's a lot of weird stuff going on, and with the new infrastructure rulings that have come out with this current administration, it's a moving target. But again, just be aware, they're never going to get rid of the qualified workers have to work in the electrical delivery zone, the qualified worker zone of a pole. So even if they allow you to use other areas of the pole, whatever, for your project, if you're attaching onto an existing asset, you still have to have qualified workers to work within certain clearances. And that kind of also brings up the distribution versus transmission rules. Basically, short version is, as of right now, you can't touch transmission or mess with it unless the utility says you can. Whereas distribution, there's a lot more leeway to request movement or kind of work. The utility has to work with you to make things happen there, versus with transmission, they don't really, because they can pull out this big stick that is the National Energy Regulatory Commission, NERC, and the Federal Energy Regulatory Commission, FERC, and say, we don't have to do anything at all because the government said we don't, is really the difference between distribution and transmission. So that's kind of the rules there. And they eat to the point where they can even be like, hey, don't touch our stuff with transmission. Whereas again, distribution, it's a little more, if you ask someone in the utility, they call it a little more Wild West. People can just do what they want. We don't like it, but you have a lot more leeway and a lot more leverage on the utility to make things happen there. So just remember that.
Perfect. Let's see. Next thing, I had crane operation here. That's, I think the big thing there is just know the various clearance distances. Teach it to your design staff, actually, because it's a lot easier if you design something that can be built without a transmission outage, and your project can get done on time, and it can get done for a lot closer to what you estimated it to cost. So that's some of the.
I'll add in that never underestimate a utility's ability to push an outage. Because what they will call your outage is a non-essential outage. Now, what that means is if they have any work that's for themselves, or outages for themselves, they come before your project. So, and this is not to say that they're not going to work with you. This is just kind of a word of caution to not make a project schedule depend on a utility outage, because it's very likely your outage will get, especially the further out you plan it and the better job you do planning it, the more possibility of it getting bumped. But on the other hand, if you force them to push a short outage or minimum outage times, you're also going to have problems. So just, again, a gentle reminder, like, to not be dependent on that and put in extra days and make sure, but don't tell the utility that you've put in the extra days in your schedule.
Yes. Which, as far as gaming outages, talk to your transmission engineers at the utility, because they will know how to game that for you. So show up to, say, like NSPE stuff and get to know them, and it'll become a lot. I don't know, maybe go to the bar next to the utility headquarters or something like that every once in a while. Basically, if you know these guys, they will probably help you a little more. Most of them are pretty decent. So, yeah. Let's see. Oh, the other thing thought of on this is your excavation around transmission poles. Well, distribution poles also. I mean, they are structures. They have a foundation of some type. They might be direct embedded. They might have drilled pier foundations, spread footings, even in some places. I mean, they're a steel structure just like any other steel structure. It's just that they hold some lines.
If you're in areas like with similar soil conditions to Iowa, you'll see a lot of driven pile type structures where they'll use like a concrete, I hate to use a concrete donut, a series of them that they drive in and then put a anchor that then are connected through it's not rebar,
basically a pile cap, right?
Yeah, pretty much. They use a pile cap, but again, they're any way they can do it more for less expense. Yes, they will put it on whatever they can. When you get into sandy areas, Oklahoma, Kansas, you'll see a lot more spread foots. When you go north or areas like, I don't know where we're at, South Dakota, and you see a lot of the lovely clay that we get out here, what you'll see is a ton of engineered fill, massive areas of engineered fill under entire substations.
Yes. I guess the point there is, work with your utility that you don't undercut their poles, their structures, their foundations. A structure failure while you're executing your project is going to be expensive. It's going to be dangerous. And your project's not going to get done when you think it's going to get done.
And I'll add in that this will be a good place. I've got some interesting structure excavation photos of what not to do.
Ooh, sounds good.
I'll have to dig those up and we can insert them into the slides here. But yes, or into the video here. But yeah, there's definitely right now you're thinking, well, that makes sense. Why would anyone ever do that? And I'm going to tell you, lots of people do that.
And I think there's kind of a blindness to my foundations had a lot of design work and a lot of floor planning, and I didn't see that happen with these. So there must not be much there.
But another interference item that I'll bring up that you don't want to do is if you're working around metal structures, all of those have specialty coatings to prevent the structures from rusting out below grade if they're direct embedded. There's a ton of direct embedded structures all over the US. If you knock that off and the utility can prove that you knocked that off, again, it's just another like, be careful when working around metal poles specifically, because there are some things where contractors and field employees don't consider them to be a fragile asset, and they can be in some ways. Yeah, in the next 5-10 years, it might not hurt anything, but a galvanized structure without protection below grade in specific soil conditions or certain areas will definitely be ready to fall over in 10 to 15 years. So, and all it takes is a good scratch on the surface of that protective coating near around in the top 18 inches of the ground line.
Which also, I have here excavation next to the pole, don't undercut it. Embankment can also cause problems because of the coating at the ground line. And if we get ground over that coating or over above it against the pole, we're going to have those same corrosion issues.
Kyle and I are extra aware of the corrosion issues because the area we work in fact, all the areas except for, no, I think all 3 areas we work in primarily have corrosive soil or the potential for corrosive soil. And so for those of you with better soil, so pretty much everywhere else in the US, it's not as big a deal. But yeah, some of the worst. And again, not something you would think of soil conditions when you're thinking of overhead power. It's a major item.
Yeah, it definitely is. It's I think the next part, actually, one thing I do want to kind of circle back on is the nature of overhead power lines. So about 3 years ago, a little over 3 years ago, I came in, didn't know anything about them, but I was going to start managing these projects. And so, went about learning as quickly as I could. Showed up to lunch and learn about conductors, sat down, and so the conductors are just steel and aluminum, and they're electric resistance heaters, and they are subject to thermal expansion, just like any other material like that. They are held up on transmission structures. They sag in a catenary, just like any other cable that you would sag that way. Structures are, you have a mechanical attachment, you have a structure of some kind. We use steel, laminated wood, just wood with guys, back to, I think it was either first or second day of statics.
You probably want an insulator in there somewhere as well.
Yes, the insulator is about the only thing that is somewhat different than what you'd be used to in any other structure. So pretty simple loading, actually. Relatively, like I said, the day one of statics, and then one of the most complicated geotechnical engineering problems that you find is direct embed poles. I remember that in college, but overall, it's pretty much a structural mechanical geotech system. So,
and to put it, I mean, to put it pretty bluntly, if you can operate most CAD systems today, you can punch in the number, you can pull everything you need, punch it into a CAD design that will give you the forces like any other CAD tool. We use PLS CAD. There's a couple others. Basically, they're structural design tools for line building, and they'll tell you whether it's going to work or not after you punch in your inputs. I mean, really, that's what your design engineers are doing at the utility. Now, there's a whole another group of engineering side that you guys will never interface with, but will dictate what a lot of those inputs are. That's called planning engineering, and they're basically doing the true electrical engineering side of that equation. Now, their job is to say, here is how we can load this line. Here's what this line is designed for. Here's how we want this line routed. Here's what we can and can't do on this line. Here are our loadings for these. And a lot of what I would call inside baseball there. The short version is you're going to work with construction engineers unless you work for a utility. And if you work for a utility, you probably know as much as we do, or more. You may know more, you may know less. Again, every
more than me, less than you.
I mean, if we're talking distribution, I'm pretty versed. If we're talking transmission, I generally am very good at it, but I don't do it as much. If we're talking substation, I left that world behind. So
Nice.
and then I guess the final area of engineering that you'll see is kind of a combination of the two in transmission line design, because we want to make sure they know these, and they're I would say they're the finickiest group of engineers you will ever meet. They're called the protection engineers. Basically, they program hard relays in the field. They are where the theory meets the real world. Just leave them alone and let them do their job.
I mean that's pretty much what I do, and if you know the inputs, if the constraints that I provided don't work, they tell me and we change it. So
yep, that's pretty much how that works with that crew.
Yes.
Like, again, lots of very specialized engineering practice. The most generalized being the construction engineers, who generally do a lot of work with combining structural and electrical engineering.
Yeah. So then let's see. We're jumping around a little bit on the outline we had, which I do that a lot. So one of the big things is NESC code provides a lot of it. And the point on this is that different clearances under the line are required for different conditions. I mean, you have one for roads that you don't fall out to the passing traffic of a legal height load. Might be agricultural, where you're able to get a tractor under it and not much else. There might be something that you'll have only pedestrian traffic, and that has a different line height. I know there are some for navigable waters. Basically, any of the conditions that make sense, they're there. And so part of the way that affects other infrastructure would be that one, if you're doing a highway, just like you have clearances with overpasses and clearance, say, next to an airport, is what I've run into transportation wise, you're going to have clearances that you need to maintain with that transmission line, or you need that transmission line rebuilt, which I guess just in general, one thing that we haven't really talked about much is the way that structure works, where you have tangent structures and you have your dead end structures. And tangents are easy to move along the line. You can move up and down the center line of that transmission line pretty easily, or distribution, of course. Your corner structures are more difficult and more expensive. Your larger lines, you have special design structures, special design foundations, and some of them might be, I'd say, $250,000 to $500,000 if you need to move one of those.
Generally speaking, yeah. And the other thing you got to remember with these are, and this is coming from doing a lot of design and distribution, normally what they call a true tangent is going to be like 0 to 5 degree line angle. Again, depending on the tighter they've built that, the closer, the less, basically the less room for error they built into it, the less angle variation they have. The short version is like 0 to 5 is a true tangent. Then you get light angle, medium angle, and then you go into heavy angle structures. Again, tangent, easy. And then you go all the way to heavy angles / dead ends. Yeah. And as Kyle said, as you go through these things, moving them, adjusting them, the heavier the angle, the more angle on it, the more difficult it is to move. The other the thing I'll also mention is, as someone who's worked for the utility, if you've ever seen a substation layout or a line layout, we like straight lines, we like 90-degree angles. That is how things are built. Until landowners become involved, that is how everything is designed.
Yes, point A to point B.
Yes. Now, yeah, and that's something we should probably also, well, no, I don't think we have to touch too much base on right away.
I don't.
Generally speaking, everybody here is going to have either dealt with right away or be actively dealing with right away if they're building that sort of structure. And outside of a few small engineering areas, yeah, you are generally not going to have to either know what it is and not need our help, or not need to know what it is at all. Lucky you.
Yes. I have an item later in this where, because of landowner, all your plans are good until you talk to the landowner, and then we end up paralleling infrastructure. And there's some considerations we need to talk about on that. First, though, as far as how do you avoid interference with a transmission line or a distribution line? I'm saying transmission mainly because that's what you really want to avoid. And distribution, yeah, it'll get moved and you're fine.
It'll either get moved, or there. The nice thing is there's a lot of clearance stuff with distribution here. I'm gonna throw something up here for the group. Like the for dummy tables, because sometimes it's nice to have those.
One point or one issue we could run into is, looks like that's copyrighted, so we might not be able to include that.
Okay, then we'll
do a link.
We can link it.
We'll link it.
Okay.
We can, yeah.
But we can't reference. We can probably throw up 232, the NESC 232 tables. I think the NESC will be okay with us sharing their tables. We'll just go to their published website probably.
Perfect.
Or we'll link the NESC tables and the Highline for Dummies version. Yeah. Anyway, now that we're going through and discussing this, since we do want to monetize these videos,
absolutely do. Yeah,
we're making money, guys. I'm sorry. I know people hate it when you do that,
but not as much as they like free PDHs.
Exactly.
Let's see. Next point I have on here is data gathering. So most of the time you get survey for your highway and you're like, oh, there's a power pole here. There's a power pole here. And let's see, I hand sketched in my field book that it goes from that pole to that pole. And that's some information. There's a power line there. However, if you want this to be usable, to check what kind of clearance you have, you need some more information. One is that, so with the conductor being an electric resistance heater that is susceptible to thermal expansion, you need to know how much it's loaded, which you don't know that, but you do know what time it is, and the utility knows how much power is going through it at that time. So you need to get the exact time and date, get the weather conditions, and that's like actual weather conditions of at the time that you're doing it, not a, oh yeah, I looked at the truck thermometer when I was setting up the control or setting up the base station that day, and it was 45 degrees. I mean, sure, now it's 80, but it was 45 degrees at the time. You need it when they're taking the shot. Novel concept.
And you need to shoot the maximum sag of the conductor, which is not at the pole. You need to shoot the dead center lowest point of the conductor where it's sagged. And I'm going to add a little additional reasoning behind why you're going to do this. Because someone like me, a standards engineer, is going to tell someone, hey, here's our sag chart. Here's how you're going to sag. Now, as I said, line crews are good and professional, but sometimes they do hand or eye sag stuff in. Now, what that means is when you check that and you give them that value, one of two things is going to happen. The utility is going to say, oh yeah, that one's to spec, or the utility is going to say, what? And I'm just saying this from experience of, if you're working on larger crossings, generally not a big deal. But let's say you're doing a residential build out in an already developed area, and you're putting a road under a line. Pretty good chance, especially with smaller distribution lines, they might have done that one by eye. And I'm going to be really honest with you, when they do that sort of thing, they're not to spec, and they're often out of clearance. So it not only helps you, it helps that utility identify places where they're out of, what's the official phrase, where they do not meet clearances. And the thing is, when you inform them of that, they have a specific window in which to correct those clearances. You want it corrected for the safety of what you're doing. The utility wants it corrected because they don't want to have to deal with it later.
Yes. And so then also, if you have a hard time finding that dead center, get as close as you can and get shots in two other places along the line on each side of that dead center, and it can be interpolated, kind of like doing a proctor.
Yeah, and again, the main thing is the utility is going to know pretty quickly if you're like, yeah, this is pretty close to center. They'll know if they're in spec or out of spec. Generally speaking, again, I've been part of mass studies of line clearances. A lot of stuff is not put into spec. There are varying reasons for it. We don't need to cover it here, but just again, if you're building a road under it, you want to know how close that is to your road. You want to shoot it. The utility will be happy to come out and fix any issues you encounter. That's the main takeaway here is, yeah, hey, if you shoot this and you give them that information, those data points that you've collected, they are not going to, if they are pushing you away or telling you they're not correct, that is very telling of that utility. And I have not met any utility engineers who would be accepting of that, or anybody in our operations groups either. So
no. And then also you are going to want to get the attachment points at the poles. You know where the pole is. It's if something is going to get redesigned, that it can be done more easily that way. So I think we beat that horse carcass pretty well.
It's dead, that's for sure.
Yeah. Okay. The next fun one. Metallic linear infrastructure paralleling transmission line. Ooh. I guess distribution can happen too. But I think transmission's probably a bigger cause of it. I know about this mostly because I've been building new transmission next to other metallic linear infrastructure. So fun thing, back to physics 2. Induction.
Favorite.
Yeah, the same concept that allows you to have vehicle detection at your traffic signals can also energize your pipeline.
And I'm going to say this, and this is from a lot of experience. So there's not enough voltage there's not enough voltage to create meaningful amounts of induction in parallel things until you get into transmission class voltages. Now, being as I've worked in substation a lot, to give you an idea of how much induction comes off, let's go with the Wheatland power plant in Wheatland, Wyoming, has a 345 kV yard. If you park a pickup in that yard for about 15 minutes, you have to slap the metal exterior of the pickup to be able to touch the door handle to get in. That doesn't happen with distribution lines. It would be very obvious if it did. So again,
Yes.
induction, and we all know physics too. Electricity flows in a linear path. When you change that path, you have some of the electrons continue to move, right? Your electricity isn't actually flowing through your conductor as much as around your conductor. Again, this is kind of a short brush up. So when you have those 90-degree angles, some of that electricity shoots off, but specifically because you have to, okay, I'm going to try to get my finger, okay, you have to sag conductor. When that conductor sags, some of those electrons shoot down to the ground. Now, again, it's not a big deal if you're talking about low voltage, but when you start getting into 115, 235, 345 kV, it's a lot of energy.
Yes. So the main takeaway there is two things. One, you need to somehow mitigate that so that when you go to maintain your pipeline, you don't get electrocuted. And also, it'll cause it to corrode really quickly.
Extremely quickly.
Yes. So cathodic protection is going to be, I assume you'd be using cathodic protection of some kind anyway. It is more vital in this case. And normally what I see is zinc ribbon installed along with a pipeline. And that pretty much takes care of it.
So, and what I've seen, they either use zinc ribbon or they double or triple their anode bags. Again, this would be what I've seen in the field. I know our gas group, I believe, uses double anode bags when they do a perpendicular crossing. I'm assuming they go up to zinc ribbon when they're paralleling.
Yes.
So again, even if you're crossing perpendicular, you need to increase the amount of cathodic protection on fittings and pipe at that crossing point. So again, that's how much energy we're talking about coming off.
Yes. You know, and on this, there are people that specialize in these studies of how to deal with, one, making sure that safety is there. I mean, that's, I would say, is probably the most important, although depending on what's in your pipeline and how high of a pressure it is, corrosion's a huge safety issue also. But there are specialists that do this, and don't wag it. Don't say, oh, I've heard of this, I'll double the bag. And
Yes.
Without knowing what you're doing, don't do that. Get somebody that does know what they're doing.
And the other thing I'll say that is a weird, when we get into large scale underground electric, the loose electricity issue, the induction is not as big of an issue. But something you do need to be aware of, if you're talking about an underground line, which we're going to see more of moving forward, people don't like lines messing up their, power lines messing up their tree lines. It's becoming a more, it's becoming a more common request to underground major transmission lines. But the induction heating off of that particular item, when it's buried in the soil, again, is going to may cause some other interesting issues, and you're going to need to be aware of the fact that you're going to run in a corridor that's going to have higher levels of soil heat. And the more heat there is, just like when you have extra electricity, the more quickly things happen.
Yeah.
So again, go ahead.
Oh yeah. So, something that's going to be interesting coming into that is we'll also start seeing more material specs that are odd requests compared to what we have going on now.
Yes.
Like we will have a more concrete that has a row value spec, which is a thermal resistivity, I believe.
Okay.
It's that row. Possibly even I've seen soil testing for that now. And that was on some kind of some heavy duty distribution stuff. But we're going to have some interesting stuff once. Oh, go ahead.
You're also going to see a lot more, I think, on the geotechnical side, soil resistivity requests.
Yeah.
There's going to be, they're going to want to know, especially with an underground line like that, they're going to want to know, they're not going to want to know resistivity at 100 points along that transmission line. They're going to want to know it every 100 feet. So that is something to be aware of for underground transmission, electric transmission, is the testing requirements are going to be a lot more, there's just a lot more testing that needs to be done in that soil along the entirety of that that transmission corridor for underground. Again, we're trying to teach you things you might need to learn about working around utilities, and this is one, or will be, there's going to be a lot more corridor studies that request both an overhead and underground option. And for that underground option, a lot more testing, specifically soil testing, is going to be required. Because I think you're right. We're going to actually need a soil row for thermal resistivity, and then an electrical resistivity test for a large portion of that, like maybe thousands of data points along those lines would be my guess. You're still muted, Kyle. We had to have one.
There we go. Of course we have to have that. I think we might have to spin this off sometime. It's something new, and instead of like a how-to sort of thing, but if we look at the implications of what kind of resources it's going to take to do these underground transmission lines, it's going to be some stuff that's outside the wheelhouse of your traditional transmission line engineers. As you said, there's going to be a whole lot more soil testing. There's going to be different material requirements.
Civil engineers rejoice.
Oh, absolutely.
Well, seriously, like you're eliminating the structural element, but you're increasing the civil element tenfold in the design process of that particular type of asset.
Definitely.
I'll use the company term asset.
Yeah. I think we might almost need to kick that to, it's going in the bucket.
Okay, into the bucket.
It's going in the bucket.
Hey, you know what? I don't have a bucket around here. We should have a bucket that we just throw things into.
So this is my fish room, as you can see. Let's see.
Oh yeah, there's a bucket.
I have buckets.
It's going into the bucket.
I am in the bucket room.
Okay, so it has gone into the bucket.
It's going in the bucket.
Okay. But anyway, yes. So paralleling, or even going perpendicular and crossing under an overhead transmission line with any metallic infrastructure, or I would even venture to say, anything with a footing.
Yeah, for the re-steel.
Yeah, for the re-steel, anything with a footing, you're gonna want to be very, very aware of what conditions can be created there Buy that
That might
transmission line.
need to go in the bucket.
Okay, in the bucket. I'm sorry.
Bucket. Resteel and corrosion from induction. Because there's a few things you can do there. I mean, epoxy coated. So that's always fun, make it more difficult to.
Yeah.
Or there's also the cathodic protection pucks that can go in a concrete structure for the resteel.
Oh yeah.
But I mean, honestly, the drilled pier shafts, so we put in at work, we don't do anything.
Well,
Maybe
that's a lot of concrete too.
Oh man, it is.
It's only a 9-foot diameter shaft. I mean, come on.
I think I did 11.
11
recently.
Nice.
Yeah, in the pit of despair.
So anyway, I see we have water and other electric as well as gas. So we've discussed gas.
Yeah.
Obviously, with water,
it's going to be those fittings.
Just make sure you're using correct fittings. Make sure your fittings have cathodic protection. Make sure that your contractors are properly installing your fittings so those collars and all of those torque bolts are installed properly, so you're not piercing a metal item into a water column, into a water feed under a power line.
Yeah.
Again, if you have to be out there for one day to inspect the job, or your inspector has to be out, that's the day you want to be there. That's kind of the takeaway.
That one.
If you need to put any small scale, 600 volt and below electric in, it has to be shielded. Not something a lot of people think about. A lot of times you are putting in some sort of, you may be putting in something, let's say you have comms cable between gas stations, you have some sort of water metering device that you need that you have an in-place comms cable that is not fiber optic installed into, you have to have shielding on that.
Hey, what about tracer wire?
That is a great question. I've never, so you can't shield it. Well, if you shield it under there, it won't work.
It won't work. Yeah.
I think, and this is just a general, I think it depends, because normally what happens with tracer wire is if there's enough energy that's running at the same phase angle as the tracer wire, you're just not going to be able to see anything. So it really depends on the overhead line and how it's feeding over that tracer wire. So if it's a single phase tracer wire, depending on how it's powered, likely you're going to lose the ability to trace under one section of that 3-phase line. If it's 60 hertz, same phase angle.
I don't quite remember. I don't know. I almost think it's direct current, because
I believe
it's not like they, but it might be okay.
I think, but again, that would be the only time if it's running. The only time it should mess with anything is if it's running, like I said, same current, same phase angle, as the overhead line that has corona coming off of it. And even then, and again, I don't do a lot with corona effect studies or working, either than hey, make sure you ground everything, guys. It's not an area that I have a ton of knowledge in, and I'm sure someone will watch this and inform us.
Oh, yes. That'll work great.
As is the rule of engineering, if we don't have an answer, someone will come out with an answer for us. But
I think there's a lot of the internet.
Yeah, there's a huge portion.
Yes, the whole, if you want to get the right answer for something, don't ask a question. you put out the wrong answer and someone will correct you.
And again, this is all from like, because we've actually had this issue with locates on single phase lines. If you have to run the same phase of single phase lines together in a trench, you can't locate that because they cancel each other out.
Oh, yeah, that makes sense.
So again, when you're talking, we don't have tracer wire when we are an electric utility because there's already a giant tracer wire in the ground.
Exactly.
So they just took onto the metal box and locate.
Yeah. So, you show up to a PDH conference and there's always going to be that one pain in the ass guy that's asking questions. You try to stump the instructor.
Yes. We don't have to deal with that.
We do it to ourselves.
Yes. Of course we do.
Yeah. Okay. So I think we're actually getting plenty of footage. We should, I'd say, wrap this up.
Yeah, I'm good with wrapping this up. I think it's a good starter. We can always cut in as much random BS as we want to.
Absolutely.
So, okay. So what is our, here's a great question for our channel. Here, I'll throw this out there. Today, we've been keeping it, I would say, PG to PG-13. Generally not too much. I mean, is there a preference? Although I am accustomed to field operations speak, I'm also fine if we keep it PG-13. We can always bunt this one to the people watching if they're okay with us being more casual.
That's a good point. Because I think if I remember right, YouTube, you can't use profanity in the first minute.
Well, that's
so we can't.
I can just barely make it that far if I'm being casual, but I'm gonna do my best for PG-13, just because again we'll try to look somewhat professional here. We do have a pretty good idea of what we're doing. I at my to give you a great idea. At my current position, I'm an entire department for standards engineering, and Kyle is the full department for 2 utilities for program management. Or for project management, excuse me. So we are pretty good, and we will do our research. And if you ask us to research something, we'll do our damnedest to figure it out. But but that being said, we don't know everything, but we do know quite a bit about this kind of stuff. So yeah, like
we're kind of at that sag point, the minimum sag of the
yes, the absolute minimum
of the
knowledge
for our position.
I love it.
No. I mean, so the was it Kruger?
Dunning, the poster for Dunning-Kruger effect? No.
Yeah, well, I think we're at the bottom of the sag there.
We're the bottom of the sag. Oh, so
I'd say we're at the bottom of the sag.
Oh, so because we don't think we know what we're doing, we don't.
Right. So either because one, we couldn't go an hour without profanity if we were at the second maximum.
Yeah.
But we don't think we know everything, so we're not the first maximum. So we're somewhere in that sweet spot sag.
Yep.
And the other fun thing is we have also realized that nobody else knows everything either. That's an important part too.
Yes. And again, I think a big takeaway from this overall is you're going to work with a lot of different engineers when you work with utilities. Generally speaking, we kind of gave you the 3: planning, protection, and physical construction engineers are kind of the 3 primary that we see. There are other areas. There are standards engineers like myself. There are tons of project managers you're going to run into. All very good, all very professional. Their job is to help you out on your projects as much as they can.
Yeah, I mean, part of it is being in that regulated monopoly position. It's the whole, well, if we don't help people out, they're going to complain to our regulators, and then it's hard to get
Yep.
stuff we want done. So yeah, people are going to help you out. Make sure you communicate and just understand that stuff takes time. Of the lead times that you might be seeing on, I don't know, steel girders for a bridge.
Ouch.
You, if the utility adjustment that you need done is going to take a steel structure, it's going to take a similar lead time, designing it and ordering it and then building it to what your project's going to take.
If you need someone to move a whole substation and a substation transformer needs to be purchased for your project, I'll see you in 2 years. Excuse me, a little more than 2 years right now.
2.5.
2.5.
2.5 lead time, so 3 years probably.
Yeah.
By the time it's all,
once it's actually installed and commissioned, yes, 3 years. But again, that's right now. Let's give you an idea. Don't ask them to move substations. They're never going to do it.
No. You don't want to pay for that either.
No. No.
So,
that's
let's see.
$20 million bill.
Yep. So communicate, get to know your fellow engineers. I mean, there's not that many engineers out there. So, say that you get along with 10% of them. There is one more friend in an engineering department you might have. So there you go.
And generally speaking, utilities run fairly lean engineering departments and again, we're talking mid-cap and smaller utilities. There are some big utilities out there, but even then, when you work with a big utility, you're usually working, unless it's really close to their central location, you're working with a regional office. Regional office has a small crew of engineers that run it when it comes to that part of it. I find that the smaller the group of engineers and people you're working with at that utility, when they have a small team, they're more responsive, they do a good job, and that's 99% of the folks in the US you'll be working with, unless you're in California or the West Coast and certain areas of the East Coast where you will work with larger utilities. And I mean, I don't even know if this qualifies for PDH for you if you live in those locations. Again, just saying that's kind of a disclaimer on our part, but for those of us that work in the rest of the continental US, pretty much small engineering groups at these utilities, less than 100 people by far, most of them less than 25 people. I mean, I don't even think we have a fairly fleshed out engineering group, and I think we'd still be under 50.
Yeah.
And we cover multiple utilities where we're at currently. So again, just kind of throwing it out there. And remember, go register at gigma.com for your free PDH.
Yes, for sure. And while you're there, register for our other service of resource leveling. You can sell some extra time you might have. You can find somebody to help you finish your project. It's a lot easier to hire somebody for exactly what you need than to hire somebody for. You can get a temporary solution to a temporary problem instead of getting a permanent solution that's not going to be in place in time for your temporary problem. And then you have to find more temporary problems to fill their time. So anyway, so we're going to be supporting you there. We are also planning on supporting your PDH requirements.
Yep.
We will be doing more. If you want to see something sounds interesting, let us know. We'll research it. We'll take a wag at it, and
I'll put on my corporate hat. If you see something, say something.
Yeah, really.
I've been told that more than once, but yeah. If you're interested in an area, especially like related to, like, we're starting out with utilities engineering because guess what? That's what we're both doing right now. But
yeah,
we have the ability to research and to learn new things, and we both kind of like doing that. So if you want us to dig into an area and do basic, I mean, really a lot of our PDHs are going to be basic overviews. I can tell you already, like, how they put together steel structures is probably on the list, with the many other things that are in the bucket. Oh wait, the buckets.
Oh yes, the buckets.
Yes.
Buckets. So buckets. We came up with underground transmission. More. How is that going to affect our industry?
Yeah.
We could do something on ethics. I'm sure we can find. Yeah, we could do ethics.
I mean, if we're gonna continue the utility thing, we got pole materials, we've got insulators and insulator materials. We have there's
deep foundations.
Of course. I mean, okay, if you want to go wild on foundations, we can go, like, I will go get the rig and we will go dig some holes.
Oh, that sounds fun.
So again, another piece of my background that I didn't throw out there was my family. My grandfather and father were both drillers, and they both installed large diameter caissons for 50, 60 years. So again, a lot of my like learning engineering was more field engineering from those two. and again, I learned a lot of interesting things about particularly our challenging area in South Dakota, and large diameter drilled pure foundations.
And I think we should throw piles in there too, just so we can talk about pile drivers. See how many innuendos.
I really want to talk about the pile driver.
The pile driver.
The pile driver.
And then we can talk about how do you pull piles.
Wasn't that your nickname in college?
I think so. the reverse pile driver.
Okay.
No. How do you drive sheet pile? You know, with a big vibrator.
Hey, how do you? Okay, you know, if we're gonna go into that sort of thing, then we got to talk about how the heck you pour bridge piers in the middle of a river or something along those lines. I mean,
ooh, that sounds fun.
Hey, you know, there's nothing like
cofferdams.
Cofferdams, or if you're gonna get, okay, if you want to do it the easy way, you get extra long permanent casing, and then you punch it in and then pump just the casing and you cheater it all the way to the top. But you didn't hear that from me.
So that's in the bucket. I know I have other stuff. I've written it down somewhere else.
Anyway, I do think we have a lot of video here.
Pavement management.
Pavement management, yes.
And I have a pet peeve on pedestrian crossings, so dabble in some traffic engineering.
We can always go into that. You know, we can even go as far as, if people are interested in, like, I think there's some interesting materials engineering topics that go with like fire safety and fire prevention that we've talked a lot about utility wise, but can be applied to a lot of other fields.
Oh yeah.
That would be interesting. Again, specifically why we do some things the way we do some things in, let's say, home and residential building, and how that applies to the utility industry, and the other way around, how some things they're doing in the utility industry might apply the other way. Again, there's a lot of fire is kind of a big deal ever since they burnt up most of California.
Yeah, and I mean, and very justifiable as a life, health, safety issue.
Yes.
Let's see other things. It might be too early to talk about the Apocalypse Engineering series.
Well, we will get there. Let's. I think that's we have to leave them with a cliffhanger. I think that's a great cliffhanger.
That's true. We can come back in and splice in. We can talk about my parents' nickname for me.
Oh.
Damn failure.
Damn failure.
Because it's a fun topic. I mean,
Yeah, damn.
it's a. Ooh, we could talk about Three Gorges. Well, no, I don't want to get assassinated by the Chinese
They won't assassinate us, mainly because, well,
because they can't get here.
they can't get here, first of all. Second of all, unless we go to dead. Wait, no, that's okay. We have to cut that part.
They still have Mr. Wu's pig.
Yeah.
Is it a herd? Pig. What is a group of pigs? Anyway.
Yeah.
So
I feel like it's a herd. Well, is it? Man, I don't know.
I mean, Google will censor our YouTube if we talk about Three Gorges, probably.
Yeah, no, for sure. So we can't do that. I mean, the nice thing is we can cut a lot of these end bits to make. I mean, we'll have to make it more concise because
definitely
we do
definitely
we kind of ramble. Let's be real here.
But that's how we get hours of PDHs.
That is true, and we have been going for quite some time.
We have.
Oh yeah, we got some good time in here. That's nice.
Oh yeah.
Okay.
We can edit stuff out, and I think we're good.
Yeah.
So
no, I agree. I will send you this file. Hopefully, I'm hoping that the recording works because that's the only thing that I'm like, oh no, is the recording okay? We're gonna find out if we didn't just totally bork this thing. I might have to go buy like an 8 terabyte massive hard drive for my. I have a monstrously overpowered computer at home.
I think company might have to buy an external hard drive
for
handoff and saving stuff.
I'm going to stop our recording now.
Perfect.
I think we're good to stop the recording.